Quantum computing meets IoT, what happens next? Welcome to our channel where we explore cutting-edge technologies and their impact on the world. Today we delve into a groundbreaking fusion, quantum computing and the Internet of Things. Both are transformative forces on their own. But when combined, they promise to redefine data processing, security, and real-time decision-making. If you are fascinated by emerging tech and want to know what comes next, please like this video and subscribe to the channel. Let us begin this journey into quantum-enhanced IoT. 1. Basics of the Internet of Things. IoT refers to networks of connected devices that collect and exchange data. These devices range from sensors and smart appliances to industrial systems and autonomous machines. However, they face constraints in computation power, energy efficiency, and security vulnerabilities. 2. Introduction to quantum computing. Quantum computing leverages quantum mechanical phenomena like superposition and entanglement. It uses quantum bits that can represent multiple states simultaneously. Quantum computers hold promise for solving complex optimization problems, cryptography, and large-scale simulations. They remain in early stages with noise, qubit coherence, and scaling as major challenges. 3. Why combine quantum computing with IoT? Classical IoT systems process data locally or in the cloud. But as sensor meshes scale up, data volume and complexity increase significantly. Quantum computing can help by accelerating machine learning, enabling complex analytics, and optimizing resource usage. It can strengthen security through quantum-resistant encryption and secure key distribution. Combining the two could unlock new levels of efficiency and intelligence in connected systems. 4. Enhanced data analytics. IoT generates massive streaming datasets from various sensors and endpoints. Traditional analytics run into computational limits at scale. Quantum algorithms designed for optimization and pattern recognition can process these datasets more effectively. This could enhance predictive maintenance, real-time anomaly detection, and sensor fusion in complex environments. 5. Optimization in IoT networks. IoT networks require efficient routing, resource allocation, and task scheduling. Quantum optimization algorithms such as QAOA can solve complex network design problems faster. Industrial IoT systems could balance loads and schedule maintenance with greater precision. 6. Quantum sensors. Quantum technology can actually improve sensors embedded in IoT networks. Quantum accelerometers, magnetometers, and gravimeters offer much higher sensitivity. Such sensors can detect minute changes, enabling applications in geophysical monitoring, navigation, and environmental sensing. These innovations will enhance data fidelity and situational awareness. 7. Architectural models. Hybrid edge cloud quantum architectures emerge as the most practical model. IoT devices operate classically while offloading specific problems to remote quantum resources. Early development is focused on low-latency quantum backends accessible via APIs. 8. Emerging quantum platforms. Industry leaders like IBM, Google, and Rigetti are offering cloud-based quantum access. Amazon Braket, Azure Quantum, and Alibaba Quantum Sandbox are becoming developer-friendly. These platforms allow IoT developers to experiment with quantum-assisted logic. 9. Quantum-inspired algorithms. Even without full quantum hardware, quantum-inspired methods can benefit IoT. Techniques such as tensor networks, quantum annealing, and simulated annealing provide near-quantum performance in classical systems. They offer practical gains in optimization, pattern recognition, and resource allocation. This is a path to near-term hybrid advantage while quantum hardware matures. 10. Skills and developer ecosystem. IoT developers will need to acquire new skills in quantum programming. Cross-domain knowledge in quantum theory, quantum-safe encryption, and hybrid architecture design becomes essential. Educational programs and online training platforms are integrating quantum topics into IoT curricula. Open-source toolkits are emerging to accelerate developer onboarding. Hardware sandbox access is critical for hands-on learning and testing. If you found this exploration insightful, please like this video to support the channel. If you want to continue following the convergence of quantum computing and IoT, subscribe to the channel and turn on notifications. Leave a comment to tell us which quantum IoT use case excites you the most. Thank you for watching. and we will see you in the next deep dive into emerging technology.